Yeah, so yeah, one of the interesting features Docker have in the new version is Docker Wasm. And just to tell you, hold on, where am I? Just to show you, I'm not lying. This is Docker.com front page at this moment. And it has been like that since KubeCon Detroit. Like 2 months ago. It's all about Wasm. The reason is Docker actually has a very complex history with Wasm. Back in 2019, Solomon Hykes, who's a co-founder of Docker, has famously said, WebAssembly is the future of computing. If WebAssembly has existed in 2008, they would not have invented Docker. But various things happened with the company and with the project. So we come full circle this year. At KubeCon, when Docker at KubeCon they launched Docker Wasm, officially supported WebAssembly as one of the container formats in the Docker toolchain. So how it started? That's the thing about because to tell the story of Docker plus WebAssembly, we have to say we have to understand what is this good for, why it's useful, right? So one of the interesting application use cases is microservices. Okay, so this is the typical microservices. It's a single purpose web service that performs a singular task in a complex system. Okay, so in this setup, it's very similar to what we call the old application server models, just to minimize application server model. So you have a database on the back end, and then you have an application server that contains the business logic and database driver in the middle, and the web server and the proxy in front, right? And each of this component is running inside a container. So, and then you orchestrate this together. Then you have a microservice, right? You have a microservice that gets in your overall architecture. This is how it started. When microservices get started, I think 5-10 years ago, it was considered to be minimized web services. Architectures like this. It's all based on Linux container. However, something really interesting happened. Just in the last month, when Elon Musk took over Twitter. One of the first things he did is to fire 90% of the guys who work there. And then he made this shit. He said, by the way, I'd like to apologize for being super slow in some countries. The application is doing over 1,000 floated batch RPCs to just render our own timeline. This is, then all the techies on Twitter start to laugh at him, right? Because he's wrong, using the wrong terminology. This is not the RPC. It's not the RPC that's the problem. It's the microservice. That's the problem. So he said, then he followed up because so many people told him, that's so wrong. So he followed up with a tweet say, I was told there's 1,200 RPCs, independent by several engineers at Twitter, which matches the number of microservices. So he basically said there's 1,200 microservices in Twitter. If you think about it, this is a fairly simple application. It's just an app that renders 140 characters. And it has over 1,000 microservices on the back end. So because those microservices are fully batched, because those microservices are fully architected, it becomes the overall performance of the application gets slow. So the climax happens, later the same day. He said, how today we'll be turning off all those microservices. He said that 80% of them are useless. Is that really true? So this is one of the I think very interesting thing because we all know Elon Musk has first principle thinking, whatever, that's so if you apply the first principle thinking for web application, you'd be really surprised why there are so many microservices around. And Twitter is by far not the most aggressive in terms of deploying microservices. For companies that we have worked with, I don't know what Shopee did, but for other internet companies we have worked with, they tend to have not thousands of microservices, but tens of thousands of microservices. And those are tens of thousands of services. And each service has multiple instances. So, it's in today's internet companies, you have a huge amount of microservices that's more or less follow the architecture I've just drawn. So what's the problem? If you have tens of thousands of microservices and each of them requires multiple containers in order to orchestrate it and start up, you got, there are some really, the performance problems of the Linux containers start really to show, right? That's a problem. Essentially, that's a problem Elon Musk has been complaining. So the first is that it's heavyweight. When Linux container, when Docker container first came out, it has, numerous people have come to me and said, they find this slide very surprising. That's because I'm calling the Linux container over heavyweight. So Linux container has always been sought to be lightweight. However, if you have tens of thousands of microservices on the back end for a single mobile app, the weight really adds up, because there's need to be dragging the whole Linux operating system along, right? And then it's slow, especially at warm-up. This has become such a big issue. I was just last month, I was in Las Vegas at the AWS re:Invent. At the opening keynote, Peter DeSantis spent 30 minutes, about 1/3 of his keynote, talking about the cold start problem of the serverless function. So AWS Lambda was called 10 trillion times a month. That's by far one of the most popular service at AWS. However, the cold start time for Java application in a Lambda function takes around 6 seconds to start up. Okay, and he was able, by recasting the image. You can listen to his keynote about how they do snapshot and things like that. They would be able to eliminate 90% of the startup time, reduce that to 600 milliseconds. However, if you think about if a microservice needs 600 milliseconds to start up and run, if you have 50,000 microservices on the back end, it's very, very slow. Your application is slow to a crawl, right? That's so in this context, even if we are not talking about a 90% performance improvement is by far not enough. We need to get it to 6 milliseconds or less, even sub-milliseconds. So we need another 2 or 3 order of magnitude improvements in order for this to be, to have sufficient performance, right? There's a general trade-off between security and overhead, right? That's in general, that's the Linux container is by default is not secure in the multi-tenancy environment. So you need things like gvisor. You need a lot of things to make it more secure, but it's also adds to the overhead line, right? And the Linux container is not portable. So the container application written for Intel CPU is not going to run ARM. It's not going to run RISC-V. So so there's I thought the battle was over. I was in Java early days. It's write once, run anywhere. I thought the battle was over by then. But in the age of container, we are fighting this battle all over again. So there's so many pinpoints when you have a large number of microservices. Right? So is there a solution for that? In fact, without WebAssembly, people still have solutions for microservices. That's why I said Twitter has over 1,000 microservices, and the application can still run reasonably. And other big internet companies have tens of thousands of microservices. They can also run reasonably. And the way to do that is batching, right? Which is a DevOps technique. That's in the interest of the time, I will not go into details of that. Essentially, it's to bundle commonly used services together into a single container. So essentially, you are developing those services independently by small teams. But at deployment time, you have to bundle them together and keep them warm, right? That's this 50 services are all together. So we put all of them into a single container. However, from our approach, this is why WebAssembly is being even considered in this space. Is that WebAssembly brings a new way to scale. That is independent of other techniques that's been deployed in this area. So first is that WebAssembly runtime can be really, really small. So because it doesn't drag in the operating system libraries. So a comparable application that's written in WebAssembly and compiled WebAssembly versus a native application that's bundled in a Linux container, there's 2 order of magnitude difference in size. So instead of tens of megabytes or 100 megabytes, we are talking about 1 megabyte, sub 1 megabytes. And it's much faster at startup time. So it's this whole notion of serverless functions needs to have hundreds of milliseconds to start up. now become the serverless functions can start up in sub-millisecond, below 1 millisecond. And it provides near native performance, meaning that a C++ application or a Rust application compiled to native and runs inside the container has performance that is similar to a Rust application that is compiled to WebAssembly. So it's but then this another interesting benefit is that it's it's quite additional security. This is why Adobe used WebAssembly to run their microservices. Is that because as we have seen in previous talk, the Docker container, the Linux container could have a very large attack surface. Because it has web server in it, it has database in it has all kinds of stuff. So there's all kinds of stuff you may forget to turn off. And it's a complex software supply chain. But with WebAssembly, you can really limit the attack surface because this is not a generic operating system. It is a VM, like a JVM, right? So secure by default is completely portable across different platforms. So that's where you see WebAssembly runtimes running on things like cars, cameras, and things like that. So the same application can run on 4 different devices. So and of course it plays well with container tools, which is which is what the Docker announcement is about, right? So why give this talk? And just up to this point, people always say you must be hiding something, because it's too good to be true. You can't have something that is 100 times smaller, 1,000 times faster, yet has no trade-off. That has exactly the same. I'm not making that claim. There is a clear trade-off from between application written for WebAssembly versus application written for Linux container. The Linux container is a general OS environment, so you can take any existing application and port it over to that environment. However, WebAssembly is different. WebAssembly requires its own toolchain, its own compilers, and its own libraries. So a lot of times you need to rewrite applications, rewrite your microservice application to WebAssembly in order to take advantage of those features. Right? So there's however there's a major effort in the community to improve the developer tooling support, which is why Docker has supported WebAssembly, and also by porting all those popular JavaScript libraries and the Rust libraries to WebAssembly, so that developers can use libraries and tools and frameworks that they are already familiar with. And then a little bit of plug. That's I'm with a project called Wasm Edge, and it's one of the leading WebAssembly runtimes. And I can go on and on about what's so great about Wasm Edge, but let's just know if you are interested in WebAssembly, check out Wasm Edge. That's all you need to know here. So then how it's going? Is WebAssembly ready for prime time? That's so here I'm supposed to give some demo, but 2 more slides before the demo. So one of the things that we have focused on is to make WebAssembly integrate better with this in development tooling. So we have Docker support with a new version of Docker Desktop. We have Containerd support, which is we work with Microsoft to push the WebAssembly runtime and WebAssembly chain into the upstream Containerd repository, and this is happening as we speak. And because Containerd support, it's because Kubernetes uses Containerd underneath that, so when we have Containerd support, we have Kubernetes. But then on the other side of the spectrum, Fedora and Red Hat has both included WebAssembly runtimes in their official distribution. So the Wasm Edge runtime is in Red Hat Enterprise Linux version 9. So this is a feat that either Docker and Java has been able to achieve, right? And I remember for a longest time, the JVM was not included in the Linux distribution. And I think even today, the Docker is not included in the Linux distribution. If you want to install Docker engine on Linux, you have to go through all those steps to specify a different RPM repository or OTP repository. And because of that, there's on that side of the river or gap, there's Podman that's equivalent to Docker, which is a command line tool that also supports WebAssembly runtimes. So there's a large array of language libraries and frameworks that has already been ported to WebAssembly. So in WebAssembly. Common Rust libraries like Tokyo, like MIO, Hyper, Request, MySQL driver, Kafka driver, Docker, and use things like that. And on the JavaScript side, you can use Node.js. You can use WebAssembly to run React SSR. You can do server-side rendering with WebAssembly and all that. So let's first have a look at a simple example that is a database-backed web service, which is another look of the graph that I showed at the beginning of the talk, right? So the idea here really is that we don't aim to run everything inside WebAssembly. However, with the support of Docker and Docker Compose, we can have mixed container environments. So meaning some services are running in Linux containers, and some services are running in WebAssembly. So again, this is a three-tier architecture of application. The database, MySQL database, still runs inside a Linux container, although there's new databases that runs inside WebAssembly. For instance, while working with guys like there's SQLite, there's DB, there's all those that can run inside WebAssembly container. But for more traditional enterprise database like MySQL, it runs inside Linux container. And on the other side, you can have we're going to talk about that Docker Cycler in a minute. But you can have a HTTP proxy, you can have Nginx, you can have Apache, and you can have all those running inside Linux container. It's the application logic, the logic that matters for your business application runs in the middle, that's run inside the WebAssembly container. And because WebAssembly container, like I said, it's 1% of the size of the Linux container that used to be in the middle. It starts out 1,000 times faster, so you can scale to zero. Meaning that when there's no requests coming in, none of those you can have all of them move out to memory. But when the requests come in, you can start them on demand in a true serverless function manner, right? That's you can start up them in sub 1 millisecond, and you can scale a lot of them, as more requests come in. So this is the architecture of this demo. Let me show you the demo. So let me show. So here is Docker desktop. It's as you can see, there's I have no container running, and if I go to my repository, we can have a Docker Compose file here. So what I do is Docker Compose. It would start up the services that I've just mentioned in here. So three containers, 2 of them Linux, and 1 of them, let me show. So here, Docker Compose has started up the network, and it has 3 services. And the first is DB1, it's MariaDB. The second is called frontend 1, it's Nginx, running on runtime like this. And the third is a backend. And there's a label here, it's called bottom 32, which indicates it's a WebAssembly runtime, right? And all 3 of them are running. And the interesting about Docker Compose allow you to specify the logical relationship between those 3. So it knows that data flows in front end and goes to the back end, and back end writes to the database, right? So it knows all that. And what we do here is that we just open the front end. Welcome to the demo, and then what we do is that we simulate, say, an e-commerce website, and then enter some data to amount $20, tax $2, shipping $1, and the shipping address 123 Main Street. Add order. What it does is that it adds to the database. It's when you hit submit, it'll go this service. This page is HTML and JavaScript. When you hit that button submit, it's use JavaScript to talk to the microservice in the middle. The microservice receives that data and makes sense of it. That's scary SQL statement and the right into the database. And then it returns the results of JavaScript so that you can see what's inside the database. But I think what's most interesting is that we go look at the images. So there's this MariaDB, 120 megabytes. We have the Nginx running on R5 in use here. It is 16 megabytes. It's under 100 megabytes only because it's on R5, which there's other limited home visit, right? The demo microservice is the entire business logic. It has the database driver, it has a connection pool, it has the HTTP server, it has all the logic, asks HTTP request, and then generates the SQL statement to user, and then generate the SQL statement to get the data out of it. It's 3 megabytes, and this is entirely optimized. I can get it down to 1 megabyte if I do some optimization. And this is unlike local tools that are not cross-platform. They can only run on Intel-based Linux platforms. And this one, the WebAssembly one can run any device that is same file. So so I think that this highlights one of the benefits of the WebAssembly runtimes. Yeah. So let me go back to my slide. I have some other demos, but I don't, but in the interest of time, I don't want to bore you. So it's you can go to the link. We're going to send out the slide after the meeting. That's showcase different some other user scenarios. For instance, in this case, it showcases the front end is no longer a website and the HTML and JavaScript. It's a Kafka view or Red Panda view. And there's inside the WebAssembly runtime, we have a number of asynchronous subscription to the queue. And so when message comes in, it knows to process the message and generate a response and send it to the database. This is also a very, very common use case. It's in the Java days we used to call the middle the application server, right? The application server, all it does is get data from the front end and the babysits the database. So that all the data transactional and properly written in the database. So that's if you go to that GitHub link, there's a Docker Compose file. That's all you need to do is what I just found. So do Docker Compose up, and it will start all the services, and then you can then you will be able to interact with the messaging queue, send it a message, and see the message stored in the database. So people say, okay, as you just said, one of the issues with WebAssembly or trade-offs with WebAssembly is need more work from the developers. So what about advanced features? They've shown basic features like HTTP server or a database connection tool. What about other things? That's because there's so many variety of different things I want to do, right? So one of the more common applications that's computationally intensive is to do microservices or serverless functions, but that's AI inference, especially with on the edge cloud, where say you have a dog camera, and but you don't want the data from your dog camera to stream all the way to AWS, for instance, and then have the image recognized there. You want it to be to run some in an edge cloud or in your home, right? That's for that you would need the microservice to be able to do AI inference, right? Give you an AI model of all the faces that's of your family members, so that it doesn't generate any alert if one of your family members appears at the door, right? So with WebAssembly, you can support AI inference with the common AI frameworks like TensorFlow, PyTorch, Rhino, and things like that. It's you can think of it's like Python. It wraps around those frameworks, and then use underlying GPU or underlying CPU architecture to run those models. And then one of the logos I showed earlier is Stammer. Stammer is one of the I'd say one of the hottest projects in microservices today. It's one of it's a spin-off project from Microsoft, and it's also a CNCF project. And what Dapper does is it's a sidecar. So through the Dapper sidecar, you can through the Dapper API, you can integrate hundreds of services that are common to the microservice environment. For instance, database, key value store, service discovery, generate HTTPS. There's just a huge array of messaging queues. There's just a huge array of services that Docker can integrate and provide to other web services containers as sidecar services. And through our collaboration with Docker, we have a WebAssembly SDK for Docker that allows developers to use Rust to access the services from the Docker sidecar. That basically allows the WebAssembly applications to have a wide variety of services, software services that are common in the microservice environment. Anyway, so I think the piece is here, right? Oh, okay. Yeah. That's so yeah, that's it for my talk, and we can have 3 questions.